Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky, the week of June 16th. This time around, when we left last week, Mars had closed right on Regulus, the bright star in the base of the sickle of Leo, and that's where it starts this week. It starts the week only about 3/4 of a degree above Regulus. You got bright red Mars, you got bright white Regulus right there together. Remember, 3/4 of a degree is less than a finger width at arm's length. So these are really close objects. You're looking west at sunset. So you're looking into the western sky there. If you've got a hazy sunset and you need binoculars to help you out, it's not that deep in the sunset, but by all means, go ahead and use the binoculars. That same night, the moon is 2/3 full still. Last week we had a moon week. We talked about stars because there was so much moon interference. We're going to have a waning moon this week, and the moon's rising after midnight. So, from 10 to midnight, you got already at the beginning of the week good observing, and it rises later each night. So we should have a pretty good week of observing ahead. The moon is in the constellation of Aquarius to start the week. So by the 22nd, by six days later, what you're going to have is Mars will have separated from Regulus by over 3 degrees, so 3 finger widths at arm's length. So you'll really see it moving out there. It gets harder and harder to see against the western horizon, but get out right after dark and just in the twilight even, maybe a little bit, and you'll be able to see as it gets dark each night. Enjoy the separation of Mars and watching it moving across there. The moon, on the evening of the 18th and 19th, the moon will have waned away to 40% full. We're talking about the morning of the 19th, just as we were talking about the morning of the 17th there, because it's rising after midnight all week. And so a 40% full moon. Last week we also talked about Neptune and Saturn sitting close to each other in the morning sky, the late night sky. About just over 1 degree, just over a finger width separates Neptune and Saturn. Binoculars will help you see Neptune in there still, so great chance to get out and see Neptune. The moon will be in that region with them, just above that pair on the morning of the 19th, 40% full. By the morning of the 22nd, the moon's waned all the way down to a beautiful 10% crescent full moon, and it sits above Venus. So now you're up early in the morning, you're watching it, and it's really early in the morning. Well, for us Northern Hemisphere folk right now, it starts to get light pretty early, so we're talking about 4 o'clock in the morning is what we're looking at right here. 4:30 in the morning maybe would be good to see a nice crescent 10% full moon sitting above bright Venus rising into the morning sky. So that's what we got with our planets, catching up with the moon and the planets that we've been watching and what they're going to do this week. In the evening sky, let's talk about the summer triangle is starting to rise now as it gets dark. So now it's 11 o'clock at night. It's good and solid dark, and Vega, one of the bright stars of the summer triangle, has risen high into the sky, and it sits in the constellation Lyra, which is this parallelogram of stars that sits below it. I didn't draw that very well, did I? The two bottom stars, the two southernmost stars in that parallelogram, these are third magnitude stars. They sit between maybe 3.2 and 3.5 magnitude. Remember, the magnitude system counts backward. A smaller number is brighter. Third magnitude is a good bright star. Most of us can see that if we don't have a heck of a lot of light pollution and a heck of a lot of smoke in the atmosphere right now that we have. And so M57 is a planetary nebula that sits between the two stars at the bottom of this parallelogram, about a third of the way down from the top star to the bottom star, that direction. That's M57, the Ring Nebula, that's known as. And the Ring Nebula is a planetary nebula, a star that has puffed off, blown off its outer layers, and left a white dwarf down below there. We'll talk about white dwarfs sometime in the coming weeks. Well, let's pick this up and run, because last week, if you watched the video we shot last week, we talked about the 4 stars of the Great Square of Pegasus, and how 3 of them were upper main sequence stars, and 1 of them was a giant star. Now, these high mass upper main sequence stars are very bright stars. We drew luminosity. We did this last week, and the temperature was increasing across this direction, and our main sequence looks like this. And we had 3 of our 4 stars were big, bright main sequence stars at the top of the main sequence, high up the main sequence. And those stars are high mass stars. We talked about last week, the higher pressure causes the temperature to be higher. And so those three stars, high mass stars, they're going to blow up in supernovae probably, unless they shed a lot of mass as they evolve, which they can do. And we can talk about that in coming weeks too. And come over here to be giant stars, and so then you ascend the giant branch, we say. You become a red giant, and then you become a horizontal branch star, helium burning star, and you move up to the asymptotic giant branch. And once you get to the asymptotic giant branch, this is the giant branch. This is the asymptotic giant branch. Once you get up here, the tip of the asymptotic giant branch, we often call that, then the star will blow off its outer layers or blow up in a supernova. If it's a lower mass star from down here that goes through this process, then it becomes a planetary nebula. And we said last week most stars are lower mass stars. So there's a lot of planetary nebulae. So it looks like this. You've got a white dwarf star in the middle, and you've got a shell of gas that gets puffed outward like this. And what's happened is this star has gotten bigger and bigger and bigger. The surface of the star has gotten pushed away from the central core of the star because the shells that are burning hydrogen into helium and helium into carbon and so out through here are getting farther and farther out. The star's getting hotter and hotter in the core, and these burning shells, these nuclear fusing shells, are getting farther out away from the central core of the star, and that's causing the to be hotter further out. Higher pressure is pushing the surface of the star out. The surface of the star cools as it gets pushed out and becomes redder, and so the surface is getting cooler while the core is getting hotter, and the star gets pushed way out. The gravity starts to have a hard time holding this surface in place because the gravitational center of the star is getting farther and farther away from the surface, and eventually, as you turn these shells on, as you ignite these shells, these are not stable stars in a lot of ways. That these shells will ignite and then shut off and ignite and shut off, and as they move out through the star. One of these ignition processes helps just blow that outer layer of the star off into space. And so you end up with a planetary nebula that often looks like a ring, but magnetic fields will change the shape. And so we have some funny shaped of these planetary nebulae. But that's what we're talking about, is a planetary nebula. It has nothing to do with planets other than the fact that they can look like planets through the eyepiece of the telescope. And so M57 is the best example of one of these, probably in the whole sky, certainly in the northern hemisphere. It's the best example of a planetary nebula. You find that in your small telescope. It's fabulous. Use a low power eyepiece to find these things. You want a medium to a higher power eyepiece for planetary nebula because they're not very big. And so, not very big. You need to magnify them so you can see that there's actually a hole. What it's going to look like? It's going to look like the bright outer shell like this, and then there's a star. It looks like a donut with maybe you can see the white dwarf star down in the core. But you've got a donut of material that's expanding out into space. So these get bigger as they get older, but they dissipate as they get older, so they get fainter. The Ring Nebula right now is about an arc minute big, about 1/60th of a degree, 1/60th of your finger width at arm's length large. That's a relatively large planetary nebula that allows you to see that with magnification, enough magnification to see this donut shape, to see what looks like a hole in the middle. And that you're looking at a bubble. If you've got a bubble of gas, when you see a bubble, you're looking through the thick part of the edge right here, and the thin, when you're looking perpendicular to the surface of the bubble, you see not much material, so you see right through it, and you see the bright part around the edge like this. So there's material here. You're just looking right through it. It's not nearly as bright. In a photograph, you'll see it start to fill in, but you won't see it at your telescope very much. So anyway, that's right there. If we drop 9 degrees down here to Phi Cygni. Phi Cygni is a 4.7 magnitude star, not very bright. A lot of us with any light pollution at all will have a hard time seeing that. But you just sort of follow that line down here. It's probably the brightest star you'll come to as you move along there. Halfway there, you cross globular cluster M56, take your telescope and enjoy that view on the way. But you're going to drop this 9 degrees. It sits 3 degrees above Albireo. Albireo is a 3rd magnitude star like these two stars. So Albireo is a brighter star than Phi Cygni. And Albireo is one of the best double stars in the sky, a nice blue-gold star combination. So use your telescope to check out that double star as well. But that's not what we're really after here. That's not our target. We're thinking about stellar evolution as we were last week, and we're thinking about planetary nebulae as the end states of low-mass stars. So we're going to turn this angle is going to be a little more than 90 degrees as we drop down here, and we're going to go another 8 degrees. out this direction. So about the same distance on down here, you're going to come to NGC 6894. And NGC 6894 is 40 to 50 arc seconds big. So it's somewhere between half and 2/3 the size of the Ring Nebula. So more magnification helps you, but it's harder to find things with more magnification. It sits about 3 degrees from 41 Cygni. 41 Cygni is a 4th magnitude star, noticeably brighter than Phi Cygni over here. So as you drop down this direction, you can use 41 Cygni to help you find this object. And this object is a more typical example of a planetary nebula. It's still a good planetary nebula. It's actually a little bit more symmetrical, more round than the Ring Nebula. But Cygnus is full of these things. So in a coming one of these little videos, we can look at the northern part of Cygnus, and we can find 2 or 3 really great examples, again, NGC objects, of more planetary nebulae in that region. So I think we'll spend a little bit of time exploring that this summer, but this is where we're going to start this week. M57, best example of a planetary nebula you can find. Slide past M56 down to Phi Cygni, turn the corner a little bit, and drop the same distance down to NGC 6894. And you've got another good example, not a great example like this, but the kind of thing you can poke around and find if you're really interested in looking for these things. So these are stars in the end states of their evolution, and they're not burning hydrogen into helium or helium into carbon or any nuclear fusion at all anymore. That's all ceased. And so they're just going to get fainter and fainter and fainter as this gas disperses out into space, and cooler and cooler and cooler. So that's what's going on with these 2 objects. So that's what we got for you this week. As always, everyone, thanks for watching, and we hope you have a great week of observing ahead.